Hello guys, CodePixel here. So today I am, well first of all I'd like to apologize for not uploading anything in a while. Summer break started and I went away for a week, and I also went to camp for a week, but now I am back and ready to make videos. And also I was busy with finals before that, so now I'm ready to make videos again. So this video is not about GL Craft. I am working on that. I haven't worked on it in a while, so I'm probably going to have to go back and look at my code again. But my next video will most likely be about that. Anyway, not before we get started, but now let's get started. So the first thing I have to the first thing I'm going to do is show you my operating system I've been developing. So my operating system is developed completely from scratch. It is not based off of a Linux. It is not made using the Linux kernel or anything. It is just a completely standalone kernel. And it does require grub to boot, though. It is programmed in assembly and C, mostly C, and I guess I'll show you, I'll demo it now. So here's the demo. I will provide a link to the binary file in the description, and if you're familiar with grub, you can use that to set it up and boot it on your own computer, which I do not recommend. You should probably try in grub. I mean, not in grub, sorry, in VirtualBox, which is what I'm doing here. But it does work on an actual computer. I have tested it on my own computer. So we'll boot it up and wait for it to boot up. Okay, here it is. I'll zoom into it. So this is just grub. I have super grub. It's grub 2, by the way. It should work with grub, but I do know for a fact it works with grub 2. So I just have a menu option here, boot to CodeOS. So this is my actual operating system. So at the beginning it says welcome to CodeOS, version 0.3, copyright 2015, CodePixel, and press any key to continue. And it boots up into a command line here, very simple. So it has a few commands that I would like to show you. First of all, sorry, just gotta unplug my headphones. The cable gets tangled sometimes. Anyway, first command I would like to show you is just the ping command. So type ping, it says pong, pretty simple. I have the help command, which I need to actually update that. I have a lot more commands than that. I will have to update that command. But anyway, we'll do set color, and you enter in a hexadecimal number. If you look up the numbers on the internet, they will have it's a 4-bit, two 4-bit colors. The first one is the foreground, and the second one is the background. So I'll do a foreground of white and a background of red. Or not, that's not red. I meant 4. 0xF4. And it sets the... Wait a minute, apparently the first number is the background. Whoops, I keep getting those two mixed up. 4F. There we go. That's what I was looking for. And if you clear the screen, it'll do that. Oh yeah, there's CLS, clears the screen. There is who is the best. As you can see, there are a few glitches still, because, you know, developing an operating system is way different than programming for higher level language, because you have complete control over every single thing the computer can and will do. So who is the best? Well, of course it's me. And I have a few file, not manipulation, but just browsing commands. I have not implemented actual file manipulation yet. The only file system it is compatible with so far is FAT16, so not FAT32 or FAT12, just FAT16. I will later add support for multiple file systems. So if you're formatting a disk under Windows, There is no FAT16 option. It just says FAT. That is FAT16. So just keep that in mind. If you're trying to read any other type of disk, it will not work. So if we type the disk info command, it'll tell you all of the it'll tell you information about the disk. So far it only works with one partition, and also another thing is it only works with the master boot record partition scheme. So if you are formatting this on a Mac, make sure to watch for that, because usually Macs format it as a GPT or a not PTR. Wow. Anyway, it tells you the starting location of the partition, the root location, which is where the root directory is, how many sectors per cluster there are, and how many root entries there are. So if we do ls, it shows me all of the shows me everything that is in the root directory, and if we look at that, that looks about right, and it shows hidden files as well. So we can see we have kernel.c and run.bat. So that works. And then we also have the change directory command, so I can change my directory to boot. And wow, okay, I guess that's another glitch there. And this does not have anything in it. So we'll just change the directory. Okay, and then let's see what else. You can change directory to include, and you can see here that's an issue as well. You can, if the directory is longer than the amount that the screen can handle, it will say press any key to continue, and it will continue listing the files. So if I try to say change directory, let's say shell.h, it'll say shell.h is not a directory. Or if I just say cd, it'll say please specify a directory. And also, it looks like the if you have plugged your disk into a Mac system before, they usually put a trashes file on the disk. So, and those are kind of weird. So if we do change directory trash one, and we list directory, you can see that if I do that, I'm still in the same directory. So you have to go back to the root directory. But anyway, oh, also the folder and file names ending with -1. So like, instead of trash it, instead of say instead of boot, let's see, what is it called? It's called boot.catalog. It just says boot, or that's a bad example. Let's say, yeah, thrashes, instead of trashes, instead of .trashes, it says trashes1. So what that means is, so FAT16 only supports 8 character long file names plus a 3-character file extension, and the period is not included in that. It just, it figures, okay, the period goes there. It's not actually written to the disk. So I can actually create a file that has a longer, like, let's say this is a really long file name, file name, and I think if I list directory, it should update on here. Yeah, see, it says this is, and then -1. So if we were to go into a hex editor and look at this, which I will do in the code section of this video, It actually is following something called the VFAT long file name. It's called VFAT long file names, and it basically changes it changes some things around so that it uh, supports longer file names, and then to anything that doesn't support it, it'll just show up with a squiggly 1 or tilde 1. So that's pretty much it for the operating system demo. So now we're going to go into the code. So all of my code for this is available on GitHub. So if you want to take a look at that, you can. So first we're going to, for the people that wanted to see the VFAT long file name format, we'll take a look at that really quick. So let me just, sorry about that. I'll open up WinHex here, and I will tools, open disk, yes, tools, open disk, let's see, which one is it? It is CodeOS. Actually, yeah, let's go to code, or let's just open generic storage device, because there's a difference. You can either take a look at each actual physical disk, or you can look at each partition. So we're gonna go to partition 1 and take new part. I don't know why it takes snapshots. Anyway, you can see that actually, fun fact, when you delete a file, it does not actually get erased off the disk. It just marks it as empty space that can be used later. So if you delete a file and you don't write anything else to the disk, chances are you'll still be able to recover it using data recovery programs. But if you write anything else to the disk, it might be overwritten. Fun fact of the day. Anyway, we're going to go to the root directory, and we'll find this is a really long file name. Find this. Find this. Okay, let's go back up here to the actual directory. Sorry about this. I'm gonna pause the video for a second while I find it. Actually, I'm gonna use this one as an example. Okay, so we can see this one's called, this is a deleted file, as you can see indicated by the 0xe5 at the beginning of it. But if we go to, or actually no, this E5 is not indicating a deleted file. This one is. But anyway, any files that are deleted have a 0xe5 as the first character instead of the first character of the file name. So if a computer supports the VFAT long file name, I don't know, if a computer supports VFAT long file names, if it sees a tilde 1 in the file name, it will look for the long file name, which is above it somewhere, and the file names have a byte at the beginning of them. The long file names have a byte in the beginning of them telling them which order to put it in. So this one says new to, and then ext document. So I'm not exactly sure how to read these, but once I figure out how to, I will add support to them into my operating system. That's about as much as I've gathered about that. And how I will do actually a tutorial on how the FAT file system is structured. So that's about it. That is it for the hex editor for now. I will make I'll probably come out with a tutorial how to read the FAT file system if anybody's interested in that. But anyway, let's look at the actual code. So I have all sorts of classes here, but first we're just going to take a look at my we're going to take a look at kernel.c. No, thank you, Notepad++. So as you can see, that was a weird sound. Coding an operating system. Hello there. No, thank you. It is just the same as regular C, except you have to compile it differently, and you don't have access to the standard libraries. But besides that, it's basically the same. And also, you can put assembly directly into your code. And why is that bracket there? I want it to be up there. That is how I do things here. Anyway, not on my watch. Anyway, it looks like I have all these nice functions here, but every single function in my code is made by me. The C that you use to make an operating system has no functions built into it. So every single function I use in my code is made by me. The only things I have to work with the only things I have to work with are the standard syntax operators and all that good stuff. And for loops I didn't even have unless you turn on an option in the compiler. But anyway, we will take a look at the print. We'll look at how you can look at the rest of the code on GitHub. I don't have time to explain all of this. But for now, let's look at the printing code. So it doesn't look like I have that. So I'll go to vga.c. Here it is. Okay. So how a computer works is when you are booted into protected mode. If you don't know what that is, look up I don't really know where to look for that, but look at OS development tutorials if you're interested in this. It'll tell you all about the different modes of CPUs and how they work. But anyway, computers all have pretty much 99.99% of computers have an accessible video memory located at the address 0xb8000, that is a hexadecimal number, and I'm not exactly sure what that converts to. I will put that in the description. But anyway, that is where it is located, and it is stored in the form of it supports a display of 80 wide by 25 tall screen, character tall, and all the characters are built into it. So you don't have individual pixel manipulation, but you can display characters on the screen. And not all characters are supported either. But, oh, geez, okay, don't move, please, thank you. And it is stored in the form of byte. Well, each character is one byte, and then there's also the next byte after a character is the attribute byte, which tells it the color and the foreground background color. So that is how that works. So let's look at the print character function, which prints out a single character onto the screen. Where is that? Put char. Here we are. So it takes a color and a character as arguments. And all of this stuff up here is just, I have variables up here that say where the cursor Y and the cursor X are, and then this line of code here converts those into a position in the array that I can use. So all I have to do to manipulate the screen is say my video memory, which is a character that is pointing to here, at the location equals whatever character I want to put, this is a space, so let's actually go down to here. So it says my video memory at the location equals the character that is put into this function, and then the location plus 1 is the color that I put into there, and then it adds the cursor X, and then it adds 1 to cursor X, and then I have a scroll function which moves it around. It's all complicated, but as you can see, I'm very bad at explaining my code, so if you want to take a look at it yourself on GitHub, you can do that. But I am going to end the video there. So thanks for watching. If you watched the whole video, extra thanks. Well, I mean, if you watched the whole video, I mean, never mind. Uh, anyway, thank you for watching. Sorry I didn't come out with a video in a while. I will come out with a video about GeoCraft sometime soon, maybe next week sometime. If depending on when I have time, because I also have an internship, so I am a little bit busy as well, but I will try to come out with a video within the next week. So thank you for watching, and bye.